Scientists knew this tree only from fossils, pressed into rock millions of years old. For decades, it was treated as completely extinct, gone long before humans ever existed to see it. Then, in the middle of a world war, a forestry professor in China stood in front of a single living tree in a small village shrine, and had absolutely no idea what he was actually looking at. In 1943, exactly one confirmed tree of this kind was known to exist anywhere in the world. It took scientists 5 more years and 2 separate misidentifications to finally realize what it really was. To understand how strange that moment really was, you have to understand what this tree was supposed to be. The dawn redwood belongs to an ancient lineage of redwoods related to the coast redwood that once dominated forests across the entire northern hemisphere. Its fossil record stretches back roughly 100 million years into the late Cretaceous period, with fossil evidence found as far apart as Western Canada, Alaska, and Russia. During its peak in the Eocene and Oligocene epochs, it formed vast forests that reached deep into the high Arctic, growing on islands that sit above 80 degrees north latitude today, a place where almost nothing grows now. Adapted to long summer daylight and equally long winter darkness in a warmer, more humid version of that climate. Starting around 15 to 20 million years ago, the planet began cooling, and the tree's range began collapsing. It disappeared from North America by the end of the Pliocene. In Asia, it held on longer, with the youngest confirmed fossil evidence dating to roughly 950,000 years ago. After that, as far as science understood it, the tree was simply gone. One more casualty of an ice age that had claimed countless other species along with it. In 1941, a Japanese paleobotanist named Shigeru Miki formally described this extinct genus for the first time, based on fossils found in Pliocene clay beds in Japan, roughly 5 million years old. Before Miki's work, fossils belonging to this tree had actually been collected for years, but were routinely misclassified as related genera because nobody had recognized the distinct arrangement of its leaves and cones. Miki resolved that confusion and gave the genus a name, Metasequoia. And with that, the tree officially existed only as rock and impression, a shape preserved in stone with no living descendant anywhere on Earth. That was the assumption, at least. Nobody had any reason to think otherwise. That same winter, on the opposite side of the world from Miki's laboratory, a professor of forest management named Kan Duo was traveling through a small village called Maodao in Hubei province, China. There, standing as part of a local shrine, was an enormous, unfamiliar tree, one that dropped its needles in winter, unlike almost every other conifer nearby. Villagers called it shui sha, water fir. Kan Duo recognized it as something unusual, but he had only bare winter branches to examine. No leaves, no cones, and nothing solid enough to identify or publish. He noted it and moved on. 2 years passed before anyone looked much closer. In July 1943, a forester named Wang Zhan was passing through the same region on an unrelated expedition, when a local school principal mentioned the strange tree and asked him to identify it. Wang detoured to Maodao, collected proper specimens this time, leaves, cones, everything needed for a real identification. And he got it wrong. He classified the tree as Glyptostrobus pensilis, a deciduous conifer that was already well known across southern China, nothing remarkable at all. That misidentification, the single known tree in Maodao sat quietly for 2 more years, unremarkable, unrecognized, sitting in a village shrine as exactly what it had always been, and nobody yet understood it. The breakthrough came almost by accident. In the summer of 1945, an assistant teacher named Chunglun Wu obtained a duplicate specimen sheet from Wang's earlier collection and brought it to Wan Chun-chung, a professor of dendrology. Chung looked at it and immediately sensed something was wrong with the earlier identification. This wasn't Glyptostrobus. This was something he didn't recognize at all, and that alone was remarkable, given how thoroughly Chinese flora had already been studied by then. To get better material, Chung sent his graduate student, Chiju Sue, back to Mudao in February 1946 to collect a fresh, more complete specimen. In April, Chung forwarded fragments of that specimen to Sen Su-hu, director of the Fan Memorial Institute of Biology in Beijing, one of the most respected botanists in the country. He examined the material and then did something nobody else had thought to do. He compared it against Shigeru Miki's 5-year-old paper describing the extinct fossil genus Metasequoia. The two specimens matched precisely, revealing a living miracle. A tree known only from ancient rock, formally declared extinct by a paleobotanist working entirely from fossils, on the other side of the world, was alive, standing quietly in a village shrine in Hubei province, and had apparently been standing there the entire time anyone had bothered to look for it. He wrote to colleagues in the United States in May to share the news, understanding immediately how significant the finding actually was. But this wasn't peacetime. The shadow of war loomed over the entire landscape. China was sliding from the end of the Second World War directly into civil war, and formal scientific publication, the kind that makes a discovery official and citable, took nearly 2 more years to complete. Hu and Chung didn't publish the full description of Metasequoia glyptostroboides until May 1948, almost 7 years after the fossil genus itself had first been named. By then, the story had already grown far larger than a single tree. In the autumn of 1947, a collector named Qingzan Hua traveled to Modao to gather seed from the original tree, funded by a modest grant from Elmer Drew Merrill at the Arnold Arboretum of Harvard University, with a small additional contribution from Ralph Works Cheney at UC Berkeley. While there, Hua pushed further into a remote area nearby called the Shuishaba Valley, and what he found changed the entire scope of the discovery completely. This wasn't one lonely survivor clinging on in a shrine. The valley held somewhere between 5,000 and 6,000 mature living trees, spread across roughly 800 square kilometers of remote mountainous terrain that had simply never been properly surveyed before. An entire hidden forest that had existed the whole time, completely unknown to modern science. Getting there and getting seed out was its own kind of ordeal. China was in the middle of a civil war. The region had no real infrastructure, forcing Hua to travel by riverboat and on foot through rugged, difficult terrain.
Hyperinflation had gutted the national currency so badly that the Arnold Arboretum's modest funding, only $250 American, had to be converted into roughly 9,750,000 units of local currency just to cover guides, labor, and transport. Despite all of that, Hua returned to Nanjing in late November 1947 with close to 2 kilograms of seed. What happened next moved remarkably fast, faster than almost anyone involved expected. On December 24th, Chung sent the very first seed shipment out of China, directly to the Arnold Arboretum. Within days, more shipments followed to the Missouri Botanical Garden, Kew Gardens in the United Kingdom, and botanical institutions in Denmark, the Netherlands, and India. When Merrill received his shipment in January 1948, he immediately redistributed it into more than 600 separate packets, sent out to 76 arboreta, universities, and gardens across North America and Europe. A tree that had existed as a single confirmed specimen only 4 years earlier was now, quite suddenly, and almost without anyone fully processing how fast it had happened everywhere. The Dawn redwood didn't just survive in cultivation once it finally reached the wider world. It thrived at a speed that surprised almost everyone who planted it. Early seedlings grew astonishingly fast, in some documented cases reaching over a meter of new growth a year. Trees planted from that original 1948 seed batch at the Cambridge Botanic Garden stood 1.5 meters tall within 4 years and had reached 17 meters by 1977. By the mid-1950s, the species had become fully commercially available in ordinary retail nurseries everywhere. Today, a comprehensive international survey found more than 2,500 verified cultivated specimens spread across nearly 50 countries, on every continent except Antarctica. A tree that existed as one confirmed shrine specimen in 1943 now lines streets, fills parks, and stands in botanical collections across the entire temperate world.
A nature reserve covering more than 600 square kilometers now provides broader ecosystem-level protection across the region too. The real problem is quieter than that, and harder to fix with a protection order. Almost no new seedlings are surviving in the wild. The open, moist mineral soil this tree needs to germinate and establish itself has largely disappeared, converted centuries ago into the rice paddies that now fill the valley floors, where young trees would otherwise take root. What's left is a forest made up almost entirely of aging adults, standing as isolated individuals along field edges, roads, and settlements, with very little coming up behind them to eventually replace them. There's a deeper complication hiding underneath the cultivated success story, too. Nearly every dawn redwood growing outside China today, all 2,500 documented specimens, and the countless more never formally recorded in parks and gardens worldwide, descend from seed collected from fewer than 10 trees during that single 1947 expedition. That means the global population, despite its enormous physical scale, carries remarkably little genetic diversity. Essentially, the genetic footprint of a handful of individuals repeated across an entire hemisphere. A pathogen or a sudden shift in climate that manages to exploit a shared weakness in that narrow genetic base could threaten an enormous number of trees at once, regardless of how many countries they happen to be planted in. Modern conservation scientists now argue that true recovery for this species would mean going back, to collect genetic material from across its full remaining wild range, not just relying on the descendants of that first narrow expedition. The tree Khan duo stood in front of in 1941, misidentified twice, before anyone truly understood what it really was, ended up rewriting what science thought was possible. A species declared extinct from fossils, studied and named without a single living leaf to examine, turned out to be alive the entire time, hidden in plain sight in a village shrine, and behind it, an entire valley nobody had thought to look in. It took 5 years to recognize what had been standing there the whole time, and less than a decade after that, it belonged to the whole world, growing in parks and gardens on continents it had never touched before, while the quiet valley where it all began kept fighting, slowly, to hold on to what was left.